Hi everyone, for today's lesson we are going to learn how to prove triangles congruent, and we're going to start with our first congruence postulate, which is side, 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 also known as SSS. Our learning targets for today are for you to be able to say, I can prove triangles congruent by side, side, side congruence postulate. For today's lesson, you are going to need the following materials. You will need something to write with, a plain sheet of paper, so it can be printer paper, it can be construction paper, whatever, plain sheet of paper. Your cutouts for side, 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 making sure that they are fully cut out, some colors, and a glue stick. So please make sure that you have all of these materials before getting started with today's lesson. So the first thing that we're going to do is we are going to discuss how to prove triangles congruent. And in our last lesson, we saw that we had to identify all of the matching angles and the matching sides that in order for triangles to be congruent. And that can be very tiresome. And so what mathematicians found is that there exist these shortcuts. So all of these that I'm about to show you, they are considered the shortcuts for proving triangles are congruent. So first thing we're going to do is we're going to take out our sheet of paper. I'm going to kind of zoom it out just a little bit, so hopefully you can see the paper. And I would like you guys to have it be long. So this is what we call hot dog style. Here's hamburger style. And we are going to fold the sheet of paper in half. So to the very best of your ability, fold this paper in half. And then from here, I would like you to please go ahead and fold the paper into thirds. So you want it to kind of match up, maybe make it loose, but you want it to fold it into one and then two. So fold it into thirds to the very best of your ability. I would argue that thirds is probably one of the toughest ones to fold. And I'm going to fold in the crease. So now I have my paper looking like this. And what we're going to do is we're going to open it back up so that we have 6 boxes. So if you need to pause the video so that you can get yourself 6 boxes, that might be an okay thing. We have a couple more things to fold in. I'm going to take this side and I am going to fold it in half all the way to the crease. And then I'm going to do the same thing on the other side, and I'm going to fold the other side in half all the way to the crease. And now all of these little lines, I am just going to cut all the way to the edge. So I'm just going to open it up. And I'm going to cut it all the way to the edge. And I'm going to do that for all of the sides. So now I have 6 tabs that we are going to be opening up. And these 6 tabs are all going to be the 5 different ways to prove triangles are congruent. And then the 6th tab is for all of the ways that do not work. So the very first one that we have is called SSS. This is known as side, side, side. SSS, which is side, side, side. Side, 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 as you can see, will have 3 different sides. So it's all about the sides. So if you can show that 3 corresponding which in other words, remember corresponding represents the word matching. If you can show that 3 corresponding or matching sides are congruent, then you have shown that the triangles are congruent. So what you'll see in your diagram is you'll see 2 different triangles. We'll label them ABC and triangle DEF. And what you're going to see is that side AB would be congruent to on one side on one triangle. Side BC would be congruent to one side on the other triangle. And side AC would be congruent with side DF on another triangle. Now, the tick marks could be in varying spots. Remember, it's all about matching up your symbols. But we would be able to say that triangle ABC is congruent to triangle DEF by side, side, side. So all you need are 3 sides to be congruent. And what this postulate is saying is that there is only one way to create a triangle that has one side having 1 tick mark, 2 tick marks, and 3 tick marks. And that is to draw it in the exact same way. If that is the case, then these 2 triangles have to be congruent because there only exists one unique triangle that would have all 3 sides being a particular length. So that's what side, side, side is trying to say. The next one is side, angle, side. SAS. This is called side, angle, side. And what this is saying in this postulate is that if you can show that a side, an angle that it's touching, and the other side of the angle, in which this angle is between 2 different sides, if you can show that 2 triangles have congruent side, then an angle, then a side, then the triangles have to be congruent. So if you can show that. So what we want to do is we want to show that 2 corresponding sides and they're included, keyword here is included, which means the angle between, included angle, are congruent. So if you can show that 2 corresponding sides and their included angle are congruent, then the triangles are going to be congruent. So you need to show that 2 corresponding sides and their included angle, which the word included angle means the angle that is between the 2 sides. So what that looks like is this. You'll have 2 triangles. We'll call them ABC and DEF. What you'll see is that the triangles will have 2 corresponding sides that are congruent and their included angle, which is the angle that is between the 2 sides. It goes side, angle, side, side, angle, side. The angle has both sides that create it. So that is the included angle. This angle right here is known as the included angle because it touches both of the sides that we are talking about. This is called the included angle. If you can show that you have 2 triangles, one that has one side, an included angle, and another side, their corresponding pieces, that you can show that they are congruent, then you can say that the triangles are congruent. Triangle ABC would therefore be congruent to triangle DEF. The next one that we have is called angle side angle, or ASA. This represents angle, side, angle. Angle, side, angle. And so these three pieces of information that is required to show that triangles are congruent, based on what we've seen up here with that SAS, ASA means that you're talking about two angles and the side that they share, which is called an included side. So if you can show that two corresponding or matching angles and their included side are congruent, then you can say that the triangles are congruent to each other. And what angle side angle looks like is that you're going to draw two triangles. We'll label them ABC and DEF. If you see in those triangles that you have two angles, like angle A is congruent to angle D, angle C being congruent to angle F, and the side that they both share, you can show that they are congruent, then that means that the triangles are congruent. This side right here that I'm going to label in pink is known as the included side. Included means between. And if you see that, that's all the information that you need in order to prove that triangles are congruent. That's it. That's all you need, because there's only one unique triangle out there that has a certain angle measure, an included side, and another angle measure. There's only one way to draw it. So therefore, we would say that triangle ABC would be congruent to triangle DEF. There only exists one unique triangle that would have these conditions. The next type is called angle side, or AAS. Notice that the side is kind of off on the side, so there doesn't exist anything that is in between. It's just known as angle side. AAS, angle side. And what you would want to show in angle side is that you would want to show that two corresponding angles and one not included side are congruent. If you can show that, then that means that you have proven that the triangles are congruent by angle side, because there only exists one unique triangle with the following parameters. So I am actually going to draw two different sets of triangles, and I'm going to put the word or in between. And this is what it looks like. So let's call this A, B, and C, D, E, F, just like before. And let's say that angle A, and we're referring to angle and angle B. Here's angle D and angle E. They all match. And the not included side would be like BC and EF. These sides do only touch one of the angles, but not the other. Same thing if I have A, B, and C, D, and E, and F. And I was once again talking about angle A and angle B, angle D and angle E. And the side that is not between would be like AC and DF. Both of these are considered angle side. And that is because we're talking about two angles and the side that only touches one of the angles, not both. So therefore, it's not included, not between. Not included. If you see that it is not included, then we would say that we would prove that these triangles, triangle ABC, would be congruent to triangle DEF by angle side congruent statement. So angle side. The last one that we have is called RHL, and this is the only SSA that works. And I'll talk about SSA in just a second. It is the only SSA that actually works. But we don't call it SSA, we call it RHL. And what RHL represents is it represents a right triangle. So you would have to prove that you have a right triangle. Hypotenuse. Hypotenuse, remember, is the longest side. And L represents leg. And leg represents just simply another side. So RHL means that if you can prove, number one, that you have a right triangle, that the hypotenuses are congruent, and the corresponding other leg is congruent, then you can say that the triangles are congruent by RHL. So what you would need to show is you would need to show that, number one, you have a right triangle. So you would have to establish that in your proof. Number two, you have congruent hypotenuses. And number three, you have corresponding legs that are congruent. If you can show that, then you can say that certain right triangles are congruent by RHL. So what I'm going to do is I'm going to draw two different sets of right triangles. And I'm going to do the best I can to try to make them congruent. And I'm going to label them A, B, C, D, E, F, A, B, C, and D, E, F. In order for you to say that you have a right triangle, you have to show that one of the angles is a right angle. If a triangle has one right angle, then it is a right triangle. Then you'll need to show that the hypotenuses are congruent. The hypotenuses is always across from the right angle. And then you'll need to show that corresponding legs are congruent. So like AB and DE would be congruent, and so because they're matching legs, we would be able to say that these triangles are congruent by RHL. You could also use BC and EF. If you show that BC and EF are congruent, then that means that you have corresponding legs that are congruent. And once again, you can prove that triangle ABC is congruent to triangle DEF by RHL. So the key word here is you need corresponding legs that are congruent. You need to have hypotenuses that are congruent, which remember that the hypotenuse is always across from the right angle. and then you need to say that you have a right triangle. And that is called RHL. Now, this last box, so these are all of the different ways to prove that triangles are congruent to each other. We have side, 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 angle, 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 side, and RHL. This last box, this is for false statements. These are the different ways that you cannot prove that triangles are congruent. These are false statements. The first one that I'm going to show you is angle, angle, angle. I'm going to put a sad face next to angle, angle, angle. Now, in order for triangles to be congruent, they need to have the same shape and the same size. But in angle, 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 I can draw two triangles that have congruent angles, but very different side lengths. For example, I know that all equilateral triangles have angles that are 60 degrees, for example. And so these angles, these triangles, they have the same angle measure and same shape, but a different size. So yes, I can draw. Is it possible to have triangles be congruent based on their angles? Absolutely. All of these triangles, you will find that if you can prove that they are congruent, then yes, all corresponding parts are congruent. But angle, 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 I cannot guarantee that just because a triangle has these certain angle measures, that the triangles have the same side lengths as well. So you always need to have a side length to compare, and that's really important. So angle, angle, angle is very sad. It does not work. We will use angle, angle, angle in a future unit, but not when it comes to congruency. So these are sad faces. In blue, tears, crying, we do not use that. The other one's called SSA. SSA is a pain in the SSA. What you have here is that, let's say that you know that two side lengths and an angle that is not included. So like something like here's A, here's B, and C. And I know that angle A is a certain angle length. And I know this side length and this side length. So this is SSA. So notice that the angle only touches one of the sides, not both. As you get further into your education of math, you will learn that there exists two different sets of triangles that can be created from SSA. And one ends up being an obtuse triangle, and the other one ends up being an acute triangle. And this one requires, we have an applet that we study in Algebra 2 with trig on this idea. But I can use this information of certain side lengths and angle measures and draw an obtuse triangle as well as an acute triangle based on SSA information. This shape or this information will provide you with triangles, or could provide you with two triangles that have both different shapes and different sizes. SSA spelled backwards is ASS. ASS is a donkey. It's another name for a donkey, and there are no donkeys in geometry is another thing that we say. So SSA is a pain in the SSA, and it does not work. Does not always work. So that's the key here. It has to always work. Side, 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 angle, 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 side, and RHL always works. But these false statements, they're false. They do not work. So I'm going to draw like a rain cloud and just rain coming out of that rain cloud. They do not work always. So I just want to put that out there that they are sad news if you see that. So I am now talking about how to prove triangles congruent, and now I'm going to transition to side, side, side. So I'm going to glue this directly into my notebook. So I'm going to flip the page. And now I'm going to take out my information on side, side, side. And I'm going to paste it in because I'm going to write some information on the side. And I'm just going to paste this directly into my notebook. And what I'm pasting here is the box that says side, side, side congruence postulate. And what this congruence postulate says is that if three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. So if three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. So what we want to do is we want to do a little bit of a matching game. So side AB has one tick mark, and so that matches with side RS. Just based on the tick marks that I see, we would say that it matches with RS. And BC matches with ST, segment ST, so they are congruent. And segment CA, remember that we have to be very particular and intentional with how we label. That C matches with T, so that's going to be TR. So if AB is congruent to RS, side BC is congruent to side ST, and side CA is congruent to side TR, then triangle ABC would be congruent to triangle A matches with R, B matches with S, and C matches with T. Triangle RST. Remember, it's all about the matching game. And so whenever we are proving triangles congruent by side, 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 we only write SSS in our proofs. So we use this phrase, SSS, for proofs. So we use just SSS for proofs. So you don't have to write the full if-then statement, because that full if-then statement is a lot to write down. Instead, we just write SSS, which is nice. So we have one more example, and that is this quick example on deciding whether or not these statements are true. So I'm just going to glue it directly into my notebook. And this example says, decide whether the congruent statement is true. So making a decision means yes or no. Which one is it? Yes or no? Decide whether the congruent statement is true. Explain your reasoning. So looking at letter A, we have triangle JKL being congruent to triangle MKL. So let's go ahead and look at this. I see that J would have to match with, or JL, which that's these two, this segment right here, JL would have to match with ML. Here's ML, and yes, they're both the segment of, or segment length of 9. I have JK, which JK would have to match with MK, and yes, they both have the length of 8. But where is that last piece? So you want to ask yourself, do the letters match? And in this case, they do. But we need one last side length. And what these two triangles share is the side length of LK. And because they share the side length of LK, we can use the reflexive property of congruence that says that a segment is congruent to itself. So yes, these two triangles are congruent by side, side, side. And that is because of this reflexive property of congruence that says that segment LK is congruent to segment LK. And I'm using LK because based on my statement, it's all about the order of the letters. I cannot emphasize that enough. When you're analyzing these, you always want to ask yourself, do the letters match with the picture? Do the letters match with the figures that you see? And in this case, it works out. And that's because of the reflexive property of congruence. Let's go ahead and look at letter B. For letter B, we have triangle RST being congruent to triangle TVW. So here is RST, and I can see that I have two tick marks on S to T. So here is ST, and it needs to match with VW according to the statement. But VW right here, so ST has two tick marks, VW has two tick marks. Okay, that works. Let's look at RT. So R to T would need to match with TW. So yes, they match up. So now we need a third congruence. Do we have that? Well, I mean, we can guess it, but it's not given. We can't use the reflexive property of congruence. We don't know any other information about midpoints or anything like that. So unfortunately, we have to say no. Even though it's probable that these two triangles are congruent, no is actually our answer. And that's because there is no way to show that segment RS is congruent to segment TV. Unfortunately, there is not enough information. So because of that, we have to say, sorry, that's not going to work. Let's go ahead and look at letter C. And letter C, let's go ahead and look at our statement. I see segment DG, so here is D to G, would have to match with HJ. HJ has two tick marks, DG has one tick mark. So unfortunately, no. Right away, this statement is incorrect. And that's because segment DG is not congruent to segment HJ. And so because of that, unfortunately, the answer is no, these two triangles are not congruent based on this congruent statement. But we can fix the congruent statement. So let's fix the congruent statement. Let's go ahead and look at this. Looks like DG, so let's start with that triangle DFG. Needs to be congruent to, what should the letters be? So DG would need to match with H and K. So it should go H and then K. And then GF would need to match with KJ. So it should be, hold on, did I do that wrong? Did I write the same exact gosh darn thing? I think I did it wrong. Sorry, guys. So we should have triangle, we have DFG. So here's DFG. So this is D to G. Sorry, guys. Should match with, so D to G should match with H and then K. So I'm sorry, I wrote down the statement incorrectly. Jeez Louise. Sorry, guys. This should be triangle H, J, and then K, because that's how they should match up. Angle D should match with angle H. Angle F should match with angle J. And angle G should match with angle K. That's how they should match. So DFG should match with HJK. That's how that should go. So this is the fixer-upper statement. And they are congruent to each other. Finally, letter D. We have triangle ABC being congruent to triangles CDA. So here is AB. AB is 3. And that should match with CD, which is 4. 3 and 4 are not congruent at all. So the answer in this case is no. And that's because segment AB is not congruent to segment CD. 3 does not equal 4. So therefore, they are not congruent to each other. And these two, we cannot say that the statement is going to work at all. All right, ladies and gentlemen, that is the end of this lesson. If you guys have any questions over anything I talked to you about side, 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 or how to prove triangles congruent, please let me know. Otherwise, I hope you have a wonderful day.